Hey there, I hope you are enjoying your 2 days without me. So if you're watching this on Thursday, you're watching this on Friday, just remember to get the assignment done before the end of the day on Friday, and I will see y'all next week. So let's talk about 2.7 on solving equations by graphing. This is a really short section, and it's going to lead us into what we're going to do in Chapter 3 and later chapters. And so our objective is that you will be able to find the x and y intercepts of a function and be able to solve equations by examining the graphs of the related functions. And so this relates to two standards for us, ACE2, which is creating equations in two or more variables and being able to use our graphs with appropriate labels, units, and scales, and then FIF4, which is the key features again. And our key features that we're really focusing on today are those intercepts. And so we're going to look at example 1 here, and this has already been graphed for us, and it is to find the x and y intercepts of the graph y is equal to 4/5 x squared plus 12/5 x minus 8. Now, I've given you the graph here. If you're not given the graph, remember that you can just go to your graphing calculator and type it in. So remember, if you're looking at your graphing calculator, right below the main screen, there's a y equals button here. You go y equals, you type in the function, and then over on the right-hand side is the word graph. You click graph, and it'll show you the picture. And you can use your zoom tools, which is in the middle right here. Hit zoom, and you can zoom in or zoom out as you need. So let's find the x and y intercepts of this graph. And so remember, the x-intercepts is where it crosses the x-axis, and so there's two of them. It crosses here at +2, and also it looks like -5. And so our x-intercepts, and we could list this one in two ways. We can just list the values themselves, or we can list the ordered pairs. So our x-intercepts are -5 and +2. The y-intercept, and if this is a function, there can only ever be one y-intercept. If it's not a function, then of course you could have more. But with a function, the y-intercept here is where it crosses the y-axis, and that is down here at -8. And so our y-intercept is -8. So again, we're just looking at the graph, pulling that information from it for this first problem. So I want to talk about a couple definitions before we get into this next section. And so we just talked about x-intercepts in the previous problem. And remember that x-intercepts are where the graph crosses the x-axis. But there's a few other words that we're going to talk about. We're going to talk about roots. We're going to talk about zeros. We're going to talk about solutions. And so remember, x-intercepts, we're dealing with a graph, and it does not have to be a function. Zeros must be for a function. So again, if I'm given a function, we'll talk about zeros of the function. Roots deal with an equation, and solutions will also be from an equation, but they all relate to the same thing. We're all talking about the x-intercepts of the graph, or when I set the equation equal to 0 and I solve for x. So I'll put a 0 in for y and solve for x. And so we could just solve this equation and find it, especially with a linear or simple quadratic like this one. But again, we're trying to do this from the graph. And so find the root of each equation by graphing the related function. And so the related function is, instead of having a 0 here, it's going to be having y equals 1/3 x plus 2. And so I go to 2. My slope is 1/3, so I'm going to go up 1, right 3. That's not taking me towards the x-axis, so I'm going to go down 1, left 3, and down 1, left 3. We see that my graph will go through -6. And so the root of the equation, also known as the solution, is -6. Again, the root is -6. Now, we will have multiple functions that will have more than one 0. And so let's take a peek at this graph. And so we have x squared minus 25 is equal to 0. Again, we'll replace the 0 with y. If we're not set equal to 0, we will make sure that the equation is set equal to 0 before we change that 0 into a y. And so this is a quadratic. We talked about quadratics in Algebra 1. And so remember that this would factor to x plus 5 and x minus 5. If you're remembering that factoring, remember that a squared minus b squared is equal to a plus b times a minus b. We're going to talk more about factoring in Chapter 3 with quadratics, but again, this is something that you should recall from Algebra 1. And so remember that if I have this, then my two zeros are at positive 5, because this one will give me positive 5, and this one will give me negative 5. And remember that our y-intercept would be negative 25, so our y-intercept is way down here, right? Down at negative 25, because that's our y-intercept. And so we go right 1 up 1, and then right 1 up 3, 1 5, 1 7, and so I'd actually end up with a point right here, right here, and right here, and then my next point would be getting me to the x-axis, and so I get our parabola shaped like this. Again, the negative 25 would be further down based on this scale. But the key is this, that when we look at the graph, where is it crossing the x-axis? It's crossing at negative 5 and positive 5. And so my roots are positive and negative 5. And again, we could list positive, negative like that, but if I had like positive 6 and negative 8, I'd just have to give both of them separately. And so our last example, very quick video here again today with 2.7. This kind of wraps up this whole chapter a little bit, kind of summarizing some of what we've done. Solving an equation by graphing. And so it says that Adrian downloaded albums to his smartphone. Each album costs $1.25. He also paid a subscription fee of $8. If the total cost for the download and the subscription fee was $15.50, how many albums did he download? And solve this by graphing the related function. And so first we have to do is write out the equation. And so understand what pieces we have. And so we're told that each album costs $1.25, and there's an $8 subscription fee, and his total cost was $15.50. So as we build this equation, it's going to be A times the $1.25, because that's the price per album. And then he also paid an $8 subscription fee. That's a one-time fee, so just plus 8 is equal to the $15.50. Now, you're probably saying, why can't I just solve this for A? And that is a perfectly legitimate method in solving an equation. But again, the skill we're working on today is being able to look at the graph to get these solutions. And so we're going to talk about how we manipulate this to get the graph of the function or the equation, and then get it from the graph. And so remember, our goal is not to get the a by itself. Our goal is to get a 0 on one side of the equation. And so the quickest way to get that is to subtract the $15.50 from both sides, because that's going to give us 0 over here. And remember, I always have to have something on both sides of an equal sign, and so if everything cancels away by addition or subtraction, I've got to be left with 0. And so I'm going to get 1.25a minus 1550 minus 8 is going to give us 750 is equal to the 0. And so remember, this becomes our y, and so I've got 1.25a minus the 7.50. And so when I go to draw this graph, let's think about our y-intercept and the slope, because this is a line, it's a linear function. And so our y-intercept is negative 7.5 way down here. Our slope is 1.25, so I'm going to go up 1 1/4, so from 7.5 that ends me up at 6.25, and right 1, so I end up about here. Then my next point will go up another 1 1/4, and it'll go to negative 5. And so we continue this pattern, and we're going to end up, as we go up and along, again going up by 1 1/4 each time, we end up crossing this at 6. And so how many albums did he download? He downloaded 6 albums. And so that's how we get it by graphing. Again, the key is this, that we have to have it set equal to 0 to be able to change that to a y to be able to graph the function. Because again, we're looking for where does it cross the x-axis. Because if we go back to our 4 words, right, x-intercepts are also known as the roots of an equation, the zeros of the function, or just the solutions. I hope This video has been short, sweet, to the point. You see that it's only not even to the 10-minute mark yet. And so I hope y'all have a great weekend, because I won't see y'all until Tuesday after the teacher workday. So y'all enjoy. Don't forget that this assignment is due by the end of the block on Friday. Adios.